talk about the area of 2D shapes. We're just going to talk about three really basic shapes that are usually used to make up larger, more complicated shapes, so we can kind of use them a lot. So we like to be really good at this groundwork here. The three shapes we're going to talk about today are just rectangles, right? 4 sides, each side parallel, and 4 right angles. Talk about triangles, 3-sided polygon. Play that up a little bit. Now we'll talk about circles. Right? We like circles a lot. We're actually going to talk about circles twice. That'll make sense in a minute. Okay, so let's take a look at rectangles first. So if you're talking about the area of a rectangle, we first have to figure out, what are we talking about? What sides are we talking about? So we call this the length of the rectangle. I write my L's in cursive just because if I write a regular L, it'll just look like a 1. There's a length L and a width W. Okay, so the length and the width, and of course, because it's a rectangle, we know that this side, this length, is going to be the same as this side over here. And then this width is going to be the same as this side over here. These dashes just denote that these sides are equal, and then the 2 dashes are equal to the 2 dashes, and so on. Okay, so to find the area of this object, all we do is area equals length times width. Simple as that. Okay, so for example, if I had a width of 3 and a length of 5, then I would say the area equals the length of 5 times the width of 3, gives us the area equal to 15. Okay, now I didn't stick any units in there, and we'll talk about that in just a moment, but we'll see how that works later on. I'm just taking it step by step here. Okay, so let's talk about this triangle. Okay, triangle is a little harder because we don't measure every side, but instead we measure the base and the height. So the base B is just the size of this line down here. Okay, and then the height is just the distance from the base to the tip of the triangle here, so that's the height there. Okay, and the formula we use is area equals base times height divided by 2. Okay, and the reason it looks a little bit like this one over here, right, because you got length times width, base times height, if you can imagine that these are instead 2 squares, and then we're just cutting them in half to find their total. Okay, so if, for example, we had a height of, say, 3 centimeters and a base of, say, 7 centimeters, okay, we would end up with area equals the 7 centimeter base times the 3 centimeter height over 2. Okay, we take 7 times 3 is 21. So 21 centimeters, and here's the key, squared, because whenever we multiply 2 units together, we get it square. So any unit times a unit equals unit squared. In this case, centimeters times centimeters equals centimeters squared. You come back here, do the division by 2, and 21 divided by 2 is 10.5 centimeters squared. It's a good way of knowing if you're talking about an area, because an area has a square unit, a volume that is the space of a 3D shape has a cubed unit, and a distance, just the distance from one point to the other, just has the straight up unit. Okay, so that's squares, that's triangles. Let's talk about circles. Now I said I'd talk about circles twice, and it's not because they have 2 different equations. We only have the one equation, but there's 2 different ways that we can have a problem set up for us to solve. Really simple to convert between them, so we'll just talk about that real quick. Usually, a circle is defined by its radius. Okay, so the radius is defined as the distance from the center of the circle to the outside of the circle. All right, so that's our radius, r. Okay, so just imagine making a point at the center of the circle and then firing a ray out to the outside of the circle. That's the radius. Okay, and our equation, a equals pi r squared, or you could also write it as a equals pi. We usually estimate as 3.14. It goes on forever. It's an irrational number. But 3.14 is usually okay for our purposes. Then times r, since r squared just means r times r. Okay, so if we had, for example, a radius of, let's say, 6 inches, okay, we'd end up with an area equal to 3.14 times 6 times 6. And of course, those would be inches. Sometimes you forget these things as you're doing the equation, but make sure they end up in there for your final answer. Okay, but you multiply all those together, you end up with the area equals 113.04 square inches. Okay, so that's one way to do this circle problem. The other way that it can be presented is with its diameter. Okay, so the diameter is twice the radius, or just the distance all the way across the circle. So that's your diameter. Okay, so another way to think about this is that if we imagine that there was a radius here, then this would be twice the radius, 2 radiuses, which means that if we take the diameter and divide it by 2, we get the radius. Right, so if we end up with the diameter, all we need to do is divide it by 2, and then we can use this equation. Okay, so for example, just give myself a little bit more room here. Oh no, I removed a part of my circle. Oh well. If we, for example, had a diameter of, say, 4 feet, we could have 4 feet divided by 2 to get our radius, and the radius would be, at that point, 2 feet, since 4 divided by 2 is 2. And then we can use our formula. The area equals pi r squared, so area equals pi times 2 feet times 2 feet, okay, which would mean that the area equals 2 times 2 is 4, times 3.14 gives us 12.56 square feet. You might have heard of that before, square feet, if you're talking about like the footage of a house. That's an area. Okay, so that is our rectangle, our triangle, and our circle. The last thing to mention here is that if you're dealing with a square, remember that a square is a rectangle. Not all rectangles are squares, but all squares are rectangles. So you can use this formula here. Okay, that's all the basic shapes and their surface area.